Welcome to this episode of the AEC Engineering and Technology Podcast, a podcast dedicated to helping engineering professionals find technology that fits their needs. This podcast is the 6th episode in our 10-episode series called Unveiling Tech Horizons. Throughout this series, we will revolutionize AEC consulting by delving into cutting-edge technologies such as AI, BIM, digital twins, PM resourcing tools, and more. In this episode, I'll be speaking with Brad Claus, Global Account Executive at VideoRay, about the innovations behind VideoRay Mission Specialist underwater robotic systems, their unique features, and adaptability. We'll also explore the applications, partnerships, and exciting future developments. With that, let's jump into today's episode. Brad, welcome to the show.
Yeah, thanks for having me.
Yeah, thank you so much for joining us today. And we've got a lot to talk about, so we'll kind of jump right into it. And for the audience to preface the interview, we actually came into contact with Brad and his team through a recent New York Times article, which we'll share in the show notes. But I'm really excited for the discussion that we've got in store for you today. But first, Brad, why don't you introduce yourself to our listeners and tell them about what you do on a daily basis?
So Brad Claus, I'm an account executive with VideoRay with focuses on offshore wind, civil, which includes hydroelectric and nuclear, aquaculture, and shipping. So more geared towards the maritime. So all of our account execs are broken off into different markets. Some of the other markets, I guess our main markets is actually the U.S. Navy and Defense. So those guys will handle typically any military around the world. In addition, all the police departments for search and rescue applications.
Wonderful. And based on that, right, what you just said, VideoRay, it sounds like has a pretty wide range of, segments, markets, and people that you guys are dealing with, huh?
That's correct. Yep.
All right. And could you just provide an overview of the VideoRay Mission Specialist underwater robotic systems? Like, what are they and how have they redefined the inspection class category?
I'd say first thing that comes to mind is power. So power, the vehicles, our Pro 5 vehicle and our Defender vehicle are best in class for performance as far as working in high currents. So both of them have the ability to overcome currents of over 4 knots, which is, doesn't sound like much, but 4 knots in current is actually moving very swiftly. Now, in addition, compared to some of our competitors, our Ethernet-based backbone, to where any accessories that you have on the vehicle, I hate to use the term plug and play, but it's truly a plug and play system compared to other products. So where the way they're set up with open architecture and modularity, in the event that you do have a failure, you could be back up and running in a matter of, say, 5 to 10 minutes. Where it doesn't require, I guess, a technician. Electrically savvy technician to where you're troubleshooting to component level items. You just have to narrow it down to an area, then swap the component out. So that technology aids for, a lot of our customers are for-profit businesses, to where having that ability to get the vehicle back up and running quickly helps them in critical path times, et cetera, to not impact their projects.
And, speaking of projects, right, just to give the listeners just a little bit more context, right, could you maybe just give like a high level, we don't need a ton of like confidential details or anything, right? Just like an example project that one of your products might be used on for your customers.
Right. So I'll focus on my markets, which is offshore wind. Some of the main tasks, I'm sure you're somewhat familiar with them. You're from Ohio, but for offshore wind, the vehicles are used for anyone at the start of the project for any inspection planning, route planning for cables, identifying where the monopiles will be installed. So it's used at the beginning of the phase and throughout the entire, life cycle of the project. So the preliminary inspection phase, the installation phase, then the life of the asset, to where there's a lot of different accessories you could put onto the vehicle, which are also used in civil markets as well. So the use of UT sensors, which will check the thickness of metal for any degradation over time. Cathodic protection, which checks for the condition of whatever anodes you have on the structure, which are used to prevent or to increase the life of that asset. In addition, any route planning. There's some pretty impressive things we're doing now with partnering with a couple of different companies with the camera technology, to where I'm sure you're familiar with the drones nowadays, to where the drones could do LiDAR, they could do full inspections. There's a handful of companies that we're working with very closely that we're doing full 3D point cloud modeling with the vehicle, to where as fast as you can inspect whatever asset, it could be a pier, a bridge, etc., all the foundations, you'll have a full 3D point cloud model built as soon as you do the inspection.
Which is really amazing, right? Because Brad,
really is.
when you're talking VideoRay, we're talking underwater inspections, we're talking underwater robotics, where right, like it's impressive enough with what robots are able to do on the surface, and you can find any number of them, right? Like Spot the Robot Dog has a lot of applications in AEC, right? But you guys are taking it to literally a different level by taking these things underwater, which is just fascinating. But one of the first questions that comes to my mind, right, is like, it's a totally different ball game when you're underwater trying to get these things to maneuver through what is essentially a different medium, right? So could you talk a little bit about like the power and the maneuverability of these robots, and like how that plays to what I assume is like a really challenging environment?
I mean, so any of the, I guess, not nearshore work, but like most of your hydroelectric type areas, I mean, current is always, I mean, they're there because of high currents to produce electricity. So current's always something to overcome. Like I mentioned before, the vehicles can work in high currents. Now, in addition, we have what we call a DVL/GPS combo. So a DVL is a sensor that's mounted onto the bottom of the vehicle. So it's used, so once the vehicle is within, say, 100 meters of bottom, it can get a bottom lock. So it knows its position in reference to bottom. So I always use the analogy, say if you want to inspect the area the size of a football field, for example, you could plot out that mission, and the vehicle will do the entire inspection on its own with limited supervision. So it'll do it on its own, but the pilot ultimately has control of it in the event of if he needs to overcome for whatever reason. It makes a decent pilot look great. And now, in addition, I mean, for station keeping as well. I mean, when you're working in these high currents, typically high current, low visibility. I mean, knowing your position. The position of the vehicle is pretty tough. So having the ability for station keeping is very advantageous as well, to where once the vehicle's near bottom, you can let go control. It'll hold station indefinitely. So if you're trying to do any enhanced sonar imagery, or like what I mentioned before with the camera, the vehicle will hold station with a steady platform to obtain the imagery. And most of what we do, I'd say 90+% of the results that customers are looking for are either sonar imagery or video imagery. So that addition or that capability enhances our product a good bit.
And could you talk a little bit more about like the mission planning, right? Is this something you're kind of doing like back at your desk, like offsite in the office before you were out in the field with the robot, or is it kind of a combination of the two?
You could do it either way. If you have a dedicated area, say you're going to inspect this bridge, you could actually pre-program the vehicle prior to where when you get into the field, it'll do the full inspection on its own. In addition, you could do it once you're on site as well. So, like for example, if you'd have the vehicle subsea, and you want to inspect, I'll call it the foundation A, B, C, or D. Once you descend the vehicle subsea, and you could actually start seeing the imagery on sonar, and that way you could do a little bit more precise mission planning when you compared to what you're actually seeing.
Gotcha.
I'm sure that makes sense.
It does. And in the case of like you mentioned, like bridge piers that are pretty much driven in and basically sit underwater for the lifetime of the structure, right?
Right.
Some of those are going pretty deep under the water line. Could you talk about the robot's capabilities to be at like these depths for extended periods of time?
I mean, the vehicles can dive indefinitely, unless of course you'd have an issue. I know we have had a couple different customers. Again, it's all scope dependent, so the need for extended dives is depending on what scope you're doing. But we've had a couple different customers that have dove our Defender vehicle for right around a 6-month time frame. So 6 months subsea with never ascending and recovering the vehicle.
And in those, like, and if you could, like, just give an example of like what type of mission would require such a prolonged period of submersion?
Typically, I mean, for that application, they were monitoring. I can't say what they were monitoring, but just monitoring whatever, a widget for an extended amount of time, and just had to have maintain a constant visual on that object.
So some asset for some extended period of time specific to that client's needs.
That is correct. Yeah.
Gotcha. Which is amazing, right? Because the versatility of these bots is so, because I mean, right, like obviously we as humans can't be submersed for 6 months like at a time, right? So this is something that just wasn't possible before the advent of these machines.
Mm-hmm.
So different organizations provide like these accessories, right, that expand the use of the vehicles for their specific use case.
Yep.
Do you have any examples of like these types of organizations and what they're doing?
Yeah, I guess without naming each of them specifically,
Absolutely.
I mean, we work with a ton of different. I guess the main ones is sonar companies. So we're doing, I mean, sonar imaging with multi-beam sonars. Like I mentioned before, camera companies. In addition, we just purchased a camera company as well, Blue Ring, which I think we're going to speak to that later on, and then manipulator companies. So of course, the vehicles, there's probably about 10 different types of manipulators we could outfit the vehicle on, or outfit the vehicle with. I guess that they all offer a different, I guess, range of power and dexterity depending on what you intend to do with the vehicle.
Understood.
So like cleaning, you could have it set up with brushes to where you're doing any biofouling cleaning, marine growth cleaning, etc. So it's depending on what your application is, and that's the beauty of what we do. I mean, for any opportunity that we work with clients, we come up with a custom solution. So it's a custom solution curtailed to their exact need. So there's so many different accessories, and that's the intent. That's what kind of our what we take pride in, is that we could build a vehicle specific to your needs.
Which is one of the amazing things about robotics is you have these machines that are just right. It's a moving object, but what other accessory or sensor that you can put on it, right? You know, cameras, LiDAR, et cetera, as you mentioned. Sounds like you can just customize it to the needs of your specific client and ultimately get the best outcome for them.
That's correct. Yep.
And I've heard one of your clients, right, the U.S. Navy, which is very, very interesting. Could you tell us a little bit about like that client and how the technology benefited them?
It's funny. I mean, the tech benefited them, but also us working with the U.S. Navy as well has benefited us as well on the technology side. So there's a lot of different products that will be coming to market, to the commercial market, which were ultimately derived from the U.S. Navy. So we've helped them, but in addition, they've helped us as well. The main applications that most militaries around the world use vehicles for are all mines. So having the ability to actually fly to an asset mine, detect what kind of mine it is, and fully disarm the mine all autonomously. And we're doing that now.
And just another great example of just putting robots in situations that are dangerous to us humans, and really capitalizing on the ability to do that.
No, in the past, I mean, you had EOD personnel, divers that would be, again, and I guess it does still happen at times, but I guess the more and more you could put a piece of equipment in its place compared to an actual person, just that removal of risk is definitely advantageous. I mean, the ROV is a tool, rather than putting a person in harm's way.
Exactly. And one experience I can draw on from, AEC experience, right? Confined space, great application for,
most definitely.
Drones are really popular, right? But any sort of robot. But let's actually switch focus to AEC, right? Like I'm curious to hear, in kind of your experience, how do VideoRay's basically systems integrate with AEC workflows, and like what type of projects are you guys seeing out there?
Yeah. Again, a lot of it's still imagery. So I mean, anything for, like I mentioned, foundations. If you want to do a full inspection, have a full 3D model of whatever assets that you have subsea. For dams, we use the vehicles to inspect dams, the faces of the dams to inspect for cracks, any anomalies, etc. Over the course of time to actually come up with a case plan to repair it, or just monitor it over time to see if they eventually need to do something. Now, in addition, we have an application to where right now the Defender is configured so power is coming from surface. So all your power goes from your OCC to the vehicle. We do have applications to where for tunnel inspections, which is kind of geared towards more of the hydroelectric side, to where we could do full tunnel penetrations up to 5,000 meters away. So we could do, I mean, you'd actually descend the vehicle down. You mentioned confined space. The vehicle would do all the mission autonomously, doing a full scan of that tunnel. Once the vehicle's recovered, you'd have again another full 3D model of everything that you would have inside of the tunnel.
Which really is amazing, right? Because I'm trying to think about how something like that would have been done in the past, where you would have essentially had like a human diver plus some sort of sensor to get down there, right?
That's correct. Yeah. I mean, again, confined space, risk. There's a lot that goes when you're putting a man, in particular a diver, in a situation like that. The risk is definitely heightened.
So we've talked about, right, it's like piers, foundations, tunnels, any other type of like, basically built world assets that you can think of that are kind of common use cases.
More geared toward the civil side, or just in any market?
I'd say AEC, but a lot of the listeners of our show are civil, so why don't we start there?
Right. Again, it's still mainly visual. I mean, visual inspections, sonar inspections. That's the tried and true. That's the main applications most of the customers in that market use it for.
Absolutely. And
now we are working to where in the future we'll have the ability to, we'll call it a resident vehicle, to where as long as you have proper communications topside, you could have a resident vehicle subsea 24/7 at that asset, to where if you need to inspect whatever, say something happens, you need to inspect this leg or this section of wall, the vehicle will always be subsea and ready for that task at any given moment. So, and again, there's a lot of different customers in like oil and gas, offshore wind, etc. That technology is fast approaching.
And I've dreamed of on my own projects, right? Essentially a robot docked, and I can call it at any time and say, hey, I want to take a closer look at this very specific part of the asset. And it sounds like it's pretty much reality for your customers today.
It is, yeah.
And Brad, you mentioned blue ring imaging earlier. Could you tell us a little bit about like the organization and kind of what they're bringing into the fold of VideoRay?
The main two things is, I mean, they have what they call OctoView and OctoCam. What I'm most excited about is actually the OctoCam. So, the same tech that you have nowadays in some of the newer vehicles, where you put your vehicle in reverse and you'll have a full 360-degree camera view of everything that's around the vehicle. You'll have that in ROV technology, to where it comes in very handy when you're piloting the vehicle in I guess difficult spots, tough areas, with lots of targets, etc. To where as you're flying the vehicle around, you can see everything that's around you, not just your forward-looking camera, anything that may be starboard, port, or behind you, to prevent you from snagging up on something, damaging the vehicle, etc. Now, in addition, they have which is OctoView. So OctoView, over the course of the next 5 years, traditionally, right now, when you fly the vehicle, you're flying through a tablet with a monitor. The OctoView technology will have it has the ability to where instead of a tablet or monitor, you'll have a headset on. So it provides I guess geospatial awareness of where you're at. Everything's through a headset. That's most of what I know about that one.
For example, right, Apple Vision Pro coming out, you're seeing a lot of different use cases in AEC, and I can see how that would be really useful to get that, like you said, geospatial awareness and better understanding of kind of what environment the robot's in versus, right, just seeing it on your monitor, of course.
Right, exactly.
Absolutely. So, Brad, looking ahead, like what other developments and advancements are you guys looking toward? Like, and how do you foresee that impacting your customers, specifically those in AEC?
Like I mentioned before, I think it's more of the true autonomy. Right now, we're doing supervised autonomy. So the true autonomy combined with the resident vehicle, to where we could do, you'd have a vehicle subsea. We could do comms up to roughly about a mile away subsea. So you do full telemetry and video subsea, to where the autonomous side, to where you have communications to it. You tell the vehicle you want it to inspect this X and Y area, and it'll do it on its own. So without the need for a pilot on site, etc., you just need any kind of a internet link or LTE signal to facilitate that the task.
Excellent. And Brad, I have to say, this has been one of the most interesting interviews, that we've had on the show, right? Because a lot of this technology is so unique and going to be new to a lot of our listeners. So we, of course, appreciate you coming on. But What's the best way for the listeners in the audience to connect with you?
They could reach me at my email, which is brad.clause@videoray.com. That's the easiest way. In addition, they could reach our sales group, which is sales@videoray.com.
Excellent. And Brad, thank you so much again for joining us today. It has been a pleasure.
Yep. Take care, Nick.
Absolutely. Please remember, you can find the show notes for this episode at aectechpodcast.com. There, you will find a summary of key points discussed in today's episode, as well as links to any of the resources, websites, or books mentioned during this episode. Until next time, I wish you the best in all of your engineering and technology endeavors. Thank you.